Okay, so today we're going to talk about the inverse property of multiplication. And basically, the reason why we use the inverse property of multiplication is to get rid of coefficients when we're solving equations. Okay, so in this particular instance, first of all, if I took the number 2, the inverse of 2 is 1/2. Okay, if I multiply those together, I'm going to get 2 over 2, which is equal to 1. This is really important because when you use the inverse, you can get rid of coefficients that you need to get rid of in solving algebraic equations. So for example, if I had 3/4 x equals, separate that, 12. The goal here is to get x by itself. The way I'm going to get x by itself is I got to get rid of 3/4. Well, using the inverse property of multiplication, I could multiply both sides of the equation because that's a rule. You do something to one side, you have to do it to the other. I can get rid of that 3/4 because I want it gone. I want to know what x is, not 3/4 x. So I'm multiplying both sides by 4/3. Here, the 4's cancel, the 3's cancel. In other words, 12 over 12 is 1. So I get x equals, I'll put a 1 here, and like I've showed you before, it's better to simplify before you multiply. So I'm going to simplify here. 3 goes into 3 1 time, 3 goes into 12 4 times, 4 times 4 is 16. Okay? So whenever you have a fraction, if you want to get rid of it, you multiply by the reciprocal. All right, so we're going to talk about a two-step equation. Before we had a one-step equation with a fraction coefficient. Now let's put it together and do a two-step equation. There's a couple of examples in the book. And one two-step equation, 2x plus 3 equals 7. That's on page 122. Here, one of the things you always have to realize is you're trying to get x by itself. Okay? So before you get rid of whatever's multiplied to the variable, you get rid of whatever's added and subtracted. You got to get rid of that first. Okay? So I want to get rid of the 3. You're going to want to do the opposite operation. It's being added. So what's the opposite operation of addition? Subtraction. So I've got to do to both sides subtract 3. Okay? When I do that, I end up with 2x, 3 minus 3 is 0, equals 4. Now I'm still working at getting x by itself, so I've got to get rid of the 2. What's happening between the 2 and the x? What's happening here? What operation? Multiply. So the opposite operation of multiply is? Divide. So I'll divide both sides by 2. Because what I do to one side, I have to do to the other. 2 divided by 2 is 1. 1 times x is x. X equals 2. 4 divided by 2 is 2. Okay? So, if we have example 2 here of 25 is equal to 1/4 n minus 3, what's the first thing I want to get rid of in solving for n? Andrew. The 3. What's the opposite operation there? Addition. So we're going to add 3 to both sides. Okay? And then I've got to still solve for n. So Junior, what do I have to get rid of to get n by itself? The 1 over 4. Junior, how do I get rid of a fraction? By the reciprocal. Okay, so we're going to multiply by the reciprocal, both sides. Okay, so when we do that, we get 112 is equal to n. Now there's some problems that students will often make mistakes with because of dealing with the positive and negative. Okay? So first of all, is that 6 positive or negative, Anthony?
Really?
BJ. It's positive. A lot of students will look at this and think it's a negative 6 because of the minus after it. That belongs to whatever's after the minus, okay? So it's a positive 6, and if I want to get rid of a positive 6, what do I have to do to both sides of the equation? Good. We're going to subtract 6. Well, when I do that, the 6 minus 6 drops out, and I have a negative 3x. 21 minus 6 is 15. And Gabe, what's the opposite operation that I need to do this time to get x by itself? Divide by negative 3, because I want to get rid of the negative also. X is equal to negative 5. All right. Sometimes we have a problem like this. What am I going to need to get rid of first? Junior. The 15. Is that positive or negative?
Positive.
So we're going to subtract 15 from both sides. All right. So I have negative w over 4. I'm trying to get w by itself. So what do I need to get rid of? Braden.
The denominator 4.
Yes, we got to get rid of the denominator 4 and the negative. So if you look at this, that is w divided by 4. What's the opposite operation, Camden? Multiply. So if I multiply both sides by negative 4, that will get rid of that negative, which I want to do. This will cancel with that, and I'll end up with w is equal to 52, negative 52.